Computer science class. You can come over here and take notes. We'll do a review of what we did last week, a quick review. Do you have a pencil or pen there? Remember, there's two things when you're doing coding. It's the lines of code that you write. Well, we'll do a quick review of last week. You can write this down in your book here. Coding just means writing lines of computer code. That consists of functions and variables, and that's it. That's all you write. Just functions and variables, nothing else. That's all you write. And programming, I hope I spelled that right. Programming is going to be writing many lines of code to do something. Writing many lines of code to do something. And that something is called a program. You're going to write a program, and a program consists of lines of code. And then you have computer science. Which is using computer programs. Actually, not using, writing computer programs. Writing computer programs to solve real world problems. Writing computer programs to solve real world problems. So you can write all of that down, please. It's a lot to write down. So it's kind of all the same, although computer science involves thinking about problems and how to solve problems. You have all that? All right. We'll write one more thing and then we'll get to the actual coding. There's only two things you are going to write when you program, and that's functions and variables. Or constants, but we'll go over the difference between a variable and a constant. Well, we'll put it right here. A function means a command that does something. Like you can make the turtle go forward, or you could make a robot go forward. It's the same. You need to understand the commands and how to use them. And then variables and constants are the same. They are two sides of the same coin, but they are the same because a variable will always evaluate to a constant. A variable is a number that can change, at least for now. And a constant is a number that cannot change. A variable might be the letter x, and then I could say x equals 5. And then if I say, what is x? What would you say? 5, yes. But now I can say x now equals 7. It was 5, but now it's 7. So what is x now? Yes, 7. So x is a variable because it can vary, which means it can change. That's all. So x is the variable, but I cannot say 7 equals 5. I can't do that. 7 cannot change. It's always 1, 2, 3, 4, 5, 6, 7. So we would say 7 does not equal 5. That's the does not equal sign. So 7 is a constant. It remains constant. Con means with. Stand? I don't know where that comes from. Maybe that just means withstanding. It withstands the change. It cannot change. So a variable can vary, a constant cannot vary. But they're the same. You can see that the x is the same as the 5. The x is the 5 and the 5 is the 5. So you are either going to write a variable or a constant, and that is it. That is all you will ever write when you are coding. A variable or a constant. Simple, right? No, it's not simple. It gets complex because we'll see. A function, you'll write a function and then you'll write a variable that will apply to some function, and then you can encapsulate that in a box, and then you'll write another function and another variable that will apply to the function, and then you'll apply those two results of those functions to another function in a larger box, and this becomes a black box, so you don't have to think about it anymore, and you encapsulate them within larger frameworks. And so it gets very complex, as you can see. But that's what building programs looks like, having these functions upon functions upon functions. So let's get into it. Let's learn the first function. Now you can see we have here a turtle in the center of the screen. There's the screen. It's supposed to be a square because this is a very old 16-bit program. We're emulating this here on a new computer. So let's pretend this is a square even though it's a rectangle. We don't have an old cathode ray tube monitor. And the turtle is heading north. You can see he's facing in the upward direction. That's the turtle. T-U-R-T-L-E, turtle. It could be a robot, whatever. It doesn't matter. And we're going to give the turtle a command. Let's write our commands over here. Commands. And the first command we will give the turtle is forward. F-O-R-W-A-R-D. And forward will take a variable or a constant that will be applied to the function forward. So the function is forward. A command is a function and variable pair. You can't just tell the turtle to move forward. He's going to say, how much do you want me to move forward? So we need, it's like telling somebody to jump. Well, how high? So forward, we'll just pick a number, 50. That's the constant. And we could say x, a variable, but we'll say 50, and the turtle will go forward 50 steps, and he's going to end up right here. Now we do have a shorthand for the command forward. The shorthand is FD. So instead of writing forward, we're going to write FD. And you can do this on your computer as well. FD. And then some number. So what happened there with the turtle? Yes, good. Yeah. So the turtle drew a line. And that's because the turtle has a pen that he's holding right here in his stomach. And as he moves, he's drawing a line as he moves. So your screen now will look like that. There'll be a line under the turtle. But let's say you did not want to do that. We don't want that line there. We just want to move the turtle forward 50 spaces without the line. There's a command, pen up, and that's PU. But before we do PU, we want to bring the turtle back home to the center of the screen. There's a command which will erase the graphics and bring the turtle back to the center of the screen. Reset graphics. And you type RG. And you're going to want to write down all of these commands. Use a separate page. Write down the list of all these commands so you have a reference sheet with all of your commands. So FD is forward. RG is reset graphics. Reset graphics will erase all of the drawing and stick the turtle back in the center of the screen. Reset graphics. Then you're going to want to take the pen up. If you want to move the turtle without drawing a line, we would type PU. Pen up. But actually, you know what? I didn't mean to get to that. Forget about that. Never mind. We'll get to that later. Let's use the pen. So let's do reset graphics. Type reset graphics. Get the turtle back to the middle of the screen. And let's say now I want to draw a square. So let's say I have to write a computer program and I need to draw some window on the screen. And so we have to draw a square. So let's think about what commands do we have to give the turtle to draw a square? Well, we have to tell the turtle to go forward, and we have to give the turtle the number of steps to go forward, which would be 50. But then the turtle will have to make a right turn. And do you remember how many degrees is a right turn? 90, exactly. So we have a circle. We have a radius. We have one little slice of the circle, and that's 1 degree. If you go all the way to a right turn, that would be 90 degrees. If we go halfway around, that's 180 degrees. We went over this last week in excruciating detail. If we go another quarter, it's 270 degrees. And if we go all the way around the circle, we go 360 degrees, or 0 degrees, because 0 degrees equals 360 degrees in the circle. So let's write our commands now to tell the turtle to draw a square. Forward, we'll pick some number, let's say 50, and then we'll turn right 90. And the right command is RIGHT, and then the constant. But we have a shorthand. We don't have to write RIGHT. We can just write RT, and that will make our typing a little simpler. RT. You're going to want to write this command down on your reference sheet for sure. Let's turn right 90 degrees. And so we're going to go forward 50, and the unit of measurement will be steps. 1, 2, 3, 4. The unit of measurement for steps is not going to be steps. We're not going 90 steps. We're simply turning in place, but we're not actually moving forward. So the unit of measurement for right will be degrees, which is turning radius around a circle. I'll put the definition of the command in parentheses and in pink, and the actual command and its constant or variable that gets applied to the command or the function in purple, blue, or whatever this color is. Given what I've given you here, can you create a square with this turtle? Oh, you did it already. Okay, yeah, look at that. Okay. I don't know how to FT. Yeah, let's do it together. Let's hit reset graphics, type RG, and then hit enter or return. We'll reset the turtle back to the middle. We'll clear the graphics. Now let's go forward 50 and right 90. And you can actually put these two commands on the same line. Forward 50, right 90. So the turtle will go forward 50 steps. It'll draw a line, and then he'll turn right. So he'll be facing to the right. Now he's waiting for the next command. Forward 50, and you put a space in between a command or the functions and the variables, and then right 90. So that's what you'll write. You can write that all on one line, and then you'll hit the return character or the end character on the keyboard. I'll write a downward arrow here. That means hit enter or return. Now that you've done that, very good. And you figured out that with the arrow keys, you can go back up on the keyboard, hit the line again, boom, hit enter, hit the line again, hit the line again, and then you're back home and you have drawn a square and the turtle is heading northward again. Very good. I'll get this on the screen here. So you drew a square and then some. Very good. All right. That way everybody can see what's going on the computer screen. All right. It looks like you went forward another 50. Now you'll notice, and this is where the power of computing comes into play. Pay attention. Pay close attention, because this is very important. If you want to do computer science, this is what you'll be working on for the next very long time, the next 70 years. This is why we have computers. Notice you had to keep repeating this command over and over. You had to hit the up arrow and then enter again, then up arrow, then enter again, then up arrow, then enter again, then up arrow, then enter again. In order to continue drawing these lines and turning right, you had to hit the up arrow and enter 3 times on the keyboard, right? Well, we don't want to keep having to go up, enter, up, enter, up, enter. So there's another command, another function that is called repeat. And this is very powerful. R-E-P-E-A-T. Repeat takes 2 variables, not 1 variable like forward and right. The first variable is a number. How many times do we want to repeat? So we'll just say 4, because we want to repeat this action forward, right, 4 times. Assuming we're not going to hit enter, we're just going to hit enter once because we're going to use our repeat. The next variable that repeat takes is a list of all the commands that you want to repeat. So the variable itself is a list of commands, and this is where we use the black box theory. You're going to take some set of commands, and it can be anything you want. It can be a 1,000-line program, and then you can repeat that and tell it how many times you want to repeat, and the command will repeat that entire program 5 times. You can put anything in there you want, and the way we define this program, we call it the black box, because once you write it, you no longer have to think about it. You encase it inside of a black box and you never have to think about it again. We just know what it does, which in this case is to draw a line and turn right. So you're going to encase whatever you want in brackets. That's the list. You put your list of commands inside the brackets. So this is called a bracket. This symbol here. You can your computer. Say bracket. B-R-A-C-K-E-T. Bracket. So what commands will we put in the bracket to make a square? Try not to go too far ahead. I know that you can do all sorts of fun stuff at home. Do you have these commands written down on your reference sheet? Make sure you write repeat. Right, repeat, and then we're going to write some number. I'm going to use 4 for this example, but it can be any number. And then you're going to write a list of other commands inside the brackets. This is called an open bracket, and the other one is called a close bracket. Let's reset the graphics. RG. We'll put the turtle back in the middle of the screen. We'll clear all the graphics. I know you want to make lots of cool stuff, but you can make even cooler stuff if you get this concept down. So please pay real close attention. We'll put the turtle on the screen in the middle. He's facing upward. There's nothing drawn. We want to go forward 50 and right 90, but we want to do this 4 times. So what would I type in the computer to get this turtle to draw a square with just one push of the return button using the commands we have here? Repeat means to do something over and over again. So we're going to encase these 2 commands. Do you know? I'll show you. We'll put these commands inside the bracket. That's our second variable that we apply to repeat. Then we'll put the word repeat before the bracket. We'll put repeat 4, and there'll be a space here and a space here around the 4. So I want you to type this entire line, repeat 4, open bracket, forward 50, right 90, closed bracket. This is as coding as it gets. You will be amazed at what we can make with just these 3 commands. You can pretty much make anything with these 3 commands, repeat, forward, and right. So write this line down. Yeah, good, that's it. Yes. Now let's see what happened. Yes, okay, so what happened? When you hit enter, it worked. We got the square, right? So now we do not have to keep finger pecking up, enter, up, enter, up, enter. We don't have to do that. Very good. Now, let's say, let me give you another definition. We'll do a little geometry here really quickly. This here is called an angle. It's a right angle, but it's an angle. This part right here is called an angle. And the way we denote an angle on the illustration is to create a little arc like that, a little quarter circle. And this is a 90-degree angle. See that right there, 90 degrees. Now the word triangle, which I'm sure you know what that is made up of the words tri, which means 3, and angle. So triangle literally means 3 angles, which means you have to take away one of these lines, one of these sides. So here is a triangle, and it turns out if you want to have a triangle where all 3 sides are the same length, this particular angle is going to be 60 degrees. The reason that's going to be 60 degrees, because if you remember when we had our circle, if you make a right angle, it's 90 degrees, and then a second right angle would be 180 degrees. And that 180 degrees creates a straight line. So if I just draw a straight line and I say, what's the angle right here? Well, it doesn't look like there's an angle, but the angle is 180 degrees, meaning we didn't actually turn. But yet, you can think of it as, yeah, we did turn, we just turned 180 degrees. So you can't see it. So it takes some out-of-the-box thinking to understand this. The way you want to understand this is, let's say there's an angle, that point right there. Let's say I wanted to go 179 degrees. The second side would go up by 1 degree. So that angle is 179, which is not a straight line, but if we go 1 degree more, that's a straight line. so it's an angle, even though it's not an angle. It's kind of crazy. So this line is 180 degrees. Well, let's say we color one of these lines a little differently. Why is this angle 60 degrees? Let's make this left side red. Well, look what happens. Oh, hold on. Put your eyes on the board. This is very profound. Listen to this. Let's say we take this red line and we move the line to the right. We're not going to change the angle. We're just going to move the line over to the right. So the line is now here instead of where it was before. What's going to happen? Let's say I extend the bottom line. Well, we know that these three angles together, let's call these angles A, angle B, and our red line is angle C. We know that these three angles together have to equal what? We have angle A plus angle B plus angle C. And those three variables together will equal, well, a straight line is how many degrees? 180, yes. So if angle A plus angle B plus angle C together make a straight line, then A plus B plus C has to equal the angle of a straight line, which is what? 180. Yes. What plus what plus what plus itself 3 times equals 18. Let's take away the 0 for a minute. What's 18 divided by 3? Or we could say, what number added to itself 3 times will equal 18? Well, if you haven't done division yet, let's see if we can figure this out another way. Yeah, close. Yeah, yes. We'll do it on the board. 1 plus 1 plus 1 equals 3. Well, that's not 18. 2 plus 2 plus 2 equals 6. That's not 18. 3 plus 3 plus 3 equals 9. That's not 18 either. 4 plus 4 plus 4 equals 12. That's not 18. 5 plus 5 plus 5 equals 15. And 6 plus 6 plus 6, and you said it before, equals 18. So remember we said 18, but we left out the 0. So we'll add the 0 back. So instead of 6 plus 6, we'll say 60 plus 60 plus 60 equals 180. So 60 plus 60 plus 60 equals 180. And so now I was able to find this angle by doing that fancy trick where I moved the line over and we had an equal angle. But now I can see, wait a minute, these are all the same angle. And when you have the same angle in all three sides, all the angles are equal. They're all equal on this one lateral. Lateral means a straight line. So we call it equilateral. So it's an equilateral triangle. All the sides are the same. So how do we make an equilateral triangle with the turtle? So we're doing forward 50 and then right, how much? Well, 90 is going to give us a right angle. 180 will give us a straight line. So yeah, we'll just go up and then we'll do a straight line and go back down. Well, what's the angle over here? 60. Well, let's try that and see what happens. So instead of right 90, let's try right 60. Now, how many sides does a triangle have? 3 or 4? 1, 2, 3. 3. Yes, good. A triangle has 3 sides. So do we repeat 4 going forward? Forward 50 is the side. So how many times do we repeat? Well, we only have 3 sides, so how many times do we want to repeat drawing a side? Yes, yeah, 3. Exactly. So this is tough stuff. This is not easy. This gets complicated fast. So repeat 3, we'll change the 4 to a 3. Repeat 3, forward 50, right 60. And let's see if that will get us what we are looking for. Type reset graphics first, RG, and then we'll start over. Ah, yes, see, that's exactly what we got. And that's not quite a triangle, is it? Oh yeah, there we got a hexagon. Yeah, so you went up and hit enter again. So what happened? Why did we not get a triangle? We're going to have to figure this out. Something is wrong. Now, when something is wrong, we have to do some kind of analysis to figure out what is wrong. Let's take a look here. The angle is 60 degrees for this triangle. So why is it that turning right 60 degrees did not result in a triangle if we turn right 3 times with 3 equal sides? Let's take a look, and you have to figure this out. You have to do what we call thinking out of the box. Here, you have to apply a different type of thinking. That's what we have to do with computers. Or just solving problems in general. So let's say let's say the turtle is facing upward, right? Let's just draw this on the whiteboard. The turtle is facing upward. Let's say he could go in the upward direction, north. Now we're going to want to draw an equilateral triangle. So the first thing we'll do is forward 50. We're going to have the turtle go 50 steps forward to about right there. Now, if we go for, we know that 90 degrees, yeah, take a look at the whiteboard here. Don't touch the computer for a moment. This is important. We know that 90 degrees is going to get you a right angle. We're going to go this way. So which is greater? 60 is greater than or less than 90? Right, yes, 60 is less than 90. So we're not actually going to go a full right angle. We're not going to go a full 90 degrees. So that's what you ended up drawing because you had 60 degrees, not even 90. So you ended up with something like that, which if you do it twice, got us a hexagon, but I didn't draw that very well. But what do we have to do to get our equilateral triangle? We want to draw something that looks like this. So while this angle in the triangle is 60 degrees, that's not what we want to turn right. We want to turn right this much in order to have 60 degrees, in order to have this ultimately be a 60-degree angle. So how much is this wide angle? How do we figure that out? If I have a straight line and I need to get this much, and I know that this angle here is 60 degrees, what equation do I do in order to solve for that first angle? Well, we know that a straight line is how many degrees? A straight line is 90 plus 90, so that's 180. So if I know this angle, let's call it x, x plus 60 equals 180. What plus 60 equals 180? Yes, 120. So we need to turn 120 degrees over here. We need to turn the turtle 120 degrees in order to get the triangle angle 60 degrees. I'm not interested in the turtle turning 60 degrees. I'm interested in the triangle having a 60-degree angle. And those are two different things. So the turtle has to turn 120 degrees in order for us to get a 60-degree angle. That's the reason you can't just start doing robotics and telling a robot where to go, because telling a robot where to go is like telling the turtle where to go. And if you don't know this, then you can't tell the robot where to go. So this is right 120. Now let's see what happens. Yeah, well, you repeat 3 because it's a triangle. You've written repeat 4 there. Let's start over actually. This is the command center down here where you're typing. I'll give you another command. It's CC, which stands for Clear Command Center. That's a new command, CC. It will clear the bottom part of the screen for you. That's not cluttered. Yeah. So write this line down right here. Write this down on your screen here. All right. So it's going to be a repeat. We're going to begin with the repeat. Good. Repeat 3. Forward. Space 50. And then we'll turn right 120 degrees. And that's going to get us our 60-degree angle on the inside. All right, go ahead and hit enter. Yeah, good. And now you created a triangle. So you can create a square, you can create a triangle, and we'll begin to figure out how to create a whole bunch of other things. So if you really want to be able to program a robot to go where you want it to go, you have to know at least a couple of geometric equations. Oh, he's going ahead. There we go. Go ahead, you can try some stuff out. There's a whole world of possibilities. Repeat 4. Forward right. You can just hit enter from the end. Yeah, so it says RT didn't report anything to FD. That's because forward takes a number, and you write RT after forward. You see, RT is being applied as a variable to the forward function. It thinks RT is the number, but the function can't do that. Make sure you put a space there. There, yeah. So now you're going to get a square, and you're already ahead. All right, well, that's fine. Keep going. Keep hitting up and down and up and down and up and down. So that brings us to another option here. You can actually put the repeat function inside of another repeat function, and I'm going to show you that now. We're going to create something that's pretty cool. Pretty cool. Yeah. Do you have all your commands? You're going to want to know these commands. So let's do this. This will begin to awaken you. What we're about to do now will awaken you to the power of why we have computers and why you want to learn them. Clear Command Center. Because we don't even have that many functions right now. The command center is the area at the bottom of the screen where you type your commands. All right, watch the board now. Take your hand off the keyboard for a minute. Let's create, pay attention here. Let's create a square. Don't actually do it right now. I'm just going to show you on the board. Just watch. Let's create a square. Now, let's say I want to, we know how to create a square, so let's go ahead and write that command on the whiteboard. Repeat, and this is called nesting. A repeat is called a loop, L-O-O-P. And we're going to put a repeat inside of a repeat. That's called nested looping. Repeat for forward 50, right 90. That right there gets us a square. So I'm going to put this squiggly bracket here and write S-Q-U-A-R-E. Let's say I want to draw a cool spirograph design. Like I'm going to make a square. I'll rotate the turtle so he'll be facing in that direction toward the right. And we're going to create another square, rotate the turtle, create another square, rotate the turtle, create another square, rotate the turtle, create another square, and so forth. And so we'll go all the way around. And so we'll make this cool design that kind of looks like that. It will look better when we do it on the computer. So what are we doing? Look on the board for a minute. I want you to have a little bit of out-of-the-box thinking here. What we're doing is we're creating a circle of squares. We're taking this square and we're writing it. We're drawing the square multiple times. So how many squares do we want? Well, let's say we want to make 36 squares. We'll pull a number out of a hat. So what I'm going to do is this creates a square. We already have the code to create a square. So let's write some new code that's going to create 36 squares. How would I create 36 squares? How would I do something over and over using these commands? Which command would we use to do something over and over multiple times? Yes, repeat. So let's write repeat over here. And I'll say I wanted 36 squares. And then I'm going to have this outer bracket with these two inner brackets. And I will repeat that. And that should draw 36 squares. Because the inner repeat will draw a single square. And the outer repeat will do that 36 times. Do you need a break? All right, that's fine. We're just getting to the meat of this thing. All right, we'll break. What's that? Break? Oh, yeah. That's all right. Repeat 36. I guess it's break time. This program is actually not easily downloadable. Do you have a laptop by any chance? You can put it on your laptop. You have to use an emulator because this is a 16-bit program. And now we have 64-bit processors. Before that, it was 32-bit. It was 32-bit process. And before that, it was 16-bit processor. Yeah, so you have to have an emulator. It's not backward compatible. Yeah. No, I don't think they want you to go back to 16-bit. It's a big conspiracy. I mean, they could if they develop the instruction set. You know, I mean, although it would be a bit of a pain. Actually, technically, it's probably better for them to just start over with a processor with a new instruction set, because they've got a brand new processor that's all pipelined and partitioned and everything, and it's yeah, technically, yes, this is an old program. This is, I think might be like from the 70s or something, or 80s. There is a new version of, yeah, we'll talk about that afterward. There's a new version. So let's go ahead and make 36 squares. So go ahead and copy this and let's see what happens. All right, so that's not quite right. Yeah, you know what, hit type RG. Let's start over here. Let's get back to where we were and then type CC. So we'll clear our command center so we don't get confused with the commands that we've already written. There you go. Now type this line right here. All you have to do is just copy the line. But actually copying is not as easy as one would think. There you go. Yeah, so we have nested repeats. A repeat within a repeat. Good. Yeah, okay, so what happened? We need a bracket on the end there. Yeah, it made 36 squares very fast. So what do we have to do in order to create this cool design? Well, after we make our square, we have to turn right. And we have to turn right every time, such that by the time we turned our 36 squares, we ended up heading back where we started, heading north. So if we want to make 36 squares, how many times do we have to make a square? How many times do we have to turn right in order to make a 360-degree circle? Yeah, so we've got 36 squares times what angle would equal 360? Well, these numbers look pretty close, 36 and 36 with a 0 after it, 360. So what do we need to write? Probably what times 36 will equal 360? I know this is beyond your pay grade a little bit. It's 10. The answer is 10. 10 times 36 will equal 360. So here in the outer square, or the outer bracket, what we can write is right 10 degrees, RT10. And then you need the outer, yeah, try that. Yeah, that's it. Does that make sense? It's kind of a new type of thinking. Now, you were able to do all of that. You were able to code that design in just one relatively short line of code. So imagine what you can do with a whole program. Oh, he's already working on the next one. So I want you to understand this idea of the nested repeats. You have a repeat within a repeat. So the first repeat there, which is in purple, makes a square. And then the second repeat, the outer repeat, makes a square and then turns right. And it does that 36 times. So let's end there. Thank you very much. And that is all for today.